I want you to imagine a scenario for a second. You sit down at your desk with your morning coffee, you open up some enterprise application, and you click a very specific sequence of 3 buttons.
Now I know exactly where this is going.
Right. Then you copy a string of text from that screen, you open a totally different legacy application, paste that text into this tiny field, hit enter, and then you just wait for a green check mark.
And then you do it again.
Exactly. Imagine doing that exact sequence like 40 times before lunch. It's the kind of hidden, just soul-crushing manual work that quietly drains hours of productivity from your week.
Yeah, and honestly, it probably drains a little bit of your sanity, too.
Definitely. We have all been there, acting as this human glue between two systems that just absolutely refuse to speak to each other.
It really is a drain, I mean, both operationally and psychologically. The most dangerous part about that specific type of manual swivel chair integration is that it becomes invisible over time.
Yeah, it really does.
We just accept it as like part of the job. People build entire daily routines around copying from system A and pasting into system B.
Right, they block off calendar time for it.
Exactly. But when you scale that invisible work across an entire enterprise, so across procurement, HR, finance, you are looking at massive, expensive bottlenecks. You are paying smart people to act like very slow, error-prone robots.
That is the perfect way to put it. We are paying humans to be bad robots.
Yeah.
And that is exactly what we are tackling today.
Yes, we are.
So the mission for this deep dive is completely hands-on. If you are listening to this, you are not getting, high-level fluff about the future of work or whatever theoretical buzzwords are trending right now.
No fluff here.
We are using our source material today to provide a highly structured, actionable learning guide into SAP Build Process Automation. We are really getting our hands dirty today.
We absolutely are. We are going to dig into the core architectural concepts, the bot execution modes, and we are going to walk through a complete step-by-step build of a sales order management automation.
By the time we wrap up this session, you are going to know exactly how to evaluate an automation use case in your own environment.
Right. You'll know how to navigate the automation editor, how to properly structure your data so the bot can actually, read it, how to configure loop logic, and finally, how to deploy the desktop agent 3.
That last part is huge.
It is crucial because that is how your automation actually breaks out of the cloud and interacts with your local physical environment. This is really about giving you the exact conceptual foundation and the configuration steps you need to go build this right now in your own SAP BTPSO Business Technology Platform Free tier account.
Okay, let's unpack this. Grab your notes, or at least mentally prepare to map out some architecture because we're diving straight in.
Let's do it.
Before we even look at a screen or write a single line of logic, we really have to start with the why.
Yeah.
I am a big believer that not every single problem needs a bot.
Absolutely.
Sometimes a bad process is just a bad process. Automating it just makes a bad process run faster. So how do we actually identify the scenarios that justify building an automation?
It fundamentally comes down to evaluating the business value versus the technical friction. In our sources, the typical enterprise use cases for these automations are things like extracting data via connectors and injecting that data into a core finance system.
Okay, makes sense.
Or maybe you have a scenario where an employee has to search for invoice numbers across countless distinct ERP instances just because the company went through a merger and nothing is consolidated yet.
Oh yeah, post-merger integration is always a mess.
It's a nightmare. Another classic example is collecting purchase requisitions from emails and distributing them to a shared services center. The overall goal is accelerating digital transformation by replacing those tedious, low-value data shuffling actions.
I get the overarching goal, definitely, but let's look at the math of those hidden tasks you mentioned earlier, because I think people assume RPA, robotic process automation, is only for massive, sprawling, multi-departmental processes. Right. Like if I am an IT director, I am usually looking for the million-dollar problems, not the little 5-minute ones.
And that is a very common and honestly very costly misconception. Our source material specifically warns against only looking for the big, complex, highly visible tasks. You actually want to hunt for the short, hidden task where you might initially think, the potential for automation is low.
Really? The short ones?
Yeah, let's do the math on that exact scenario you opened with. Say it takes you 5 minutes to do that specific copy-paste task, and you do it 40 times a day.
Okay, so that's 200 minutes.
Right, that is over 3 hours of your day just gone.
3 hours just acting like a human network router.
Exactly.
Yeah.
Now, multiply that. Imagine you have 50 people in your shared services center doing that exact same thing, which, by the way, is incredibly common in large organizations.
Yeah, I've seen it.
If you build a bot to automate that one simple 5-minute task, the source calculates you are saving approximately 12 full-time equivalents.
Wait, really? 12 full-time positions?
12 full-time employees worth of hours recovered just by automating a 5-minute data entry loop. That is where the immediate savings and the reduction in cycle times become mathematically undeniable.
That is wild.
And you aren't replacing those 12 people, right? You are freeing up 12 people's worth of brain power to actually analyze the data rather than just moving it from screen to screen.
I see the math, but here is where I have to push back a little bit on the architecture. If the goal is just getting two digital systems to talk to each other, moving data from a web form into a legacy asset management system, why not just build a web service or an API?
Ah, the API question.
Yeah, because as someone with a development background, building a bot that clicks on a screen feels, I don't know, a little bit like a Band-Aid. It feels brittle. An API feels like the proper IT way to integrate systems. Why use SAP Build Process Automation when I could just write a Python script and hit an API endpoint?
That is the classic developer argument. And I mean, in a perfect frictionless world, you are entirely correct. APIs and web services are fantastic.
Right.
They are robust, they operate below the UI layer, and they really are the gold standard for integration. But they exist in the real world of enterprise constraints. Our sources explicitly highlight what we can call the API dilemma, which comes down to time, budget, and legacy debt.
Okay, unpack that for me.
Well, developing a new web service or even modifying an existing enterprise API requires significant development time. It is never just writing a script. It requires mandatory security audits, compliance checks, regression testing, and deployment cycles.
That is fair. You can't exactly just slap an unauthorized API onto a highly regulated legacy finance system over the weekend without the chief information security officer, like, having a heart attack.
Exactly. The compliance hurdle alone can take 6 months. Furthermore, sometimes adding a user-friendly programmatic interface to a 20-year-old on-premise system is just prohibitively expensive.
Yeah, the vendor probably charges a fortune for that.
Oh, massive amounts. Or consider this incredibly common scenario. A massive system migration to SAP S/4HANA is planned, but it is 3 years away. The business needs relief today.
Right, they can't wait.
They cannot wait 3 years for the new API architecture, but IT absolutely refuses to invest budget into modifying the old system that is just going to be retired anyway.
Oh man, the classic, we are freezing development on the old system excuse. Meanwhile, the operations team is just drowning in manual work.
That is the exact technical gap that RPA fills. It doesn't require rebuilding the underlying architecture. It doesn't require touching the database layer at all.
Because it works on the surface.
Yes, it just mimics the human interacting with the existing presentation layer, the user interface. It is a tactical tool. You use RPA to bypass the IT development backlog, basically solving the immediate operational hemorrhage without requiring a massive architectural overhaul.
That reframes it perfectly for me. It is not replacing the API. It is deploying a tactical bridge when the API is either too expensive, too slow to build, or politically impossible to get approved. So here is your first action item as you listen to this deep dive. Map out your own daily workflow or the workflow of the team you support. I want you to identify one repetitive process that relies on cross-application copy-pasting.
And take notes on it.
Right. Note the time spent on it versus the actual complexity of the task. If it requires a human to look at it, but not to actually think about it, that is your prime candidate for what we are about to build.
And once you have that use case in mind, you have to decide how you want the automation to run architecturally. This brings us to the core execution modes in SAP Build, which are unattended mode and attended mode. How a bot operates fundamentally changes how we design its logic and error handling.
Okay, let's break those down. Unattended versus attended. I am assuming unattended means it runs on a server somewhere in a dark room.
Essentially, yes. Unattended mode means the bots work completely autonomously. There is zero human intervention during the part of the process the RPA is running.
So no one is watching it.
Right. It runs on a dedicated virtual machine or a server. It wakes up based on a specific trigger, like maybe an API call, a scheduled timer, or a new file dropping into a folder, executes its logic, processes the data, and goes back to sleep.
So it's really like a batch processing script running at 2 a.m. Because there is no human there, If it encounters an error like, say, a pop-up window appears that the bot wasn't expecting, it can't ask for help. It just has to fail gracefully and log the error.
Precisely. That means your error handling in unattended mode has to be incredibly
I
robust.
got it. And what about the other one?
Attended mode, on the other hand, is when the bot works alongside a human user on their actual workstation. It acts as a digital assistant. The human is usually the one who triggers it.
Give me a real-world example of attended mode. How does that actually look to the user?
Imagine a call center agent. A customer calls in, and the agent needs to pull up records from a CRM, a billing system, and a shipping database.
All while the customer's waiting on hold.
Exactly. Instead of manually logging into all three and searching, the agent types the customer's phone number into a tiny prompt on their screen and hits go. The attended bot takes over the agent's mouse and keyboard for about 5 seconds, rapidly pulls the data from all three systems, compiles it into a single view, and hands control back to the human.
Oh, I love that. The bot might even, like, pause to ask the human for a decision. Like, I found 2 accounts with this name. Which one should I process before continuing? It's truly collaborative.
It is. It is a partnership.
Okay.
So we know the business justification and we know our execution modes. Now we need to know where we actually construct this logic. Let's look at the SAP Build Automation Editor workspace.
Okay.
This is the integrated development environment, the IDE, and it runs right in your browser.
To make this digestible, let's use an analogy. If
Mhm.
you are listening, think of the automation editor as an aircraft cockpit. When you first open it up, it can look a bit overwhelming, with panels and buttons everywhere.
Screens.
Right. But this cockpit is divided into 4 very specific control panels. If you understand these 4 panels, you can fly the plane.
The cockpit metaphor works perfectly here because it really is all about instrumentation and knowing exactly where to look.
Let's walk through them.
The first panel, spanning right across the top of your screen, is the toolbar. This is your standard pre-flight control center. It holds your simple, universal actions. So undo, redo, delete a step, save your automation.
The basics.
Yep. And crucially, it holds the test button, which compiles your logic and runs it in debug mode.
Okay, so toolbar is on top, pre-flight checks, and the big test button. What is the main focal point?
Dead center is the workflow canvas. This is the main screen of your cockpit. It is the visual representation of your logic, and it executes strictly top to bottom.
Like a flowchart.
Exactly. As you build, this canvas will populate with a flowchart of actions. First, open application. Next, click button. Next, read text. It is the actual flight path your bot is going to take.
But the canvas starts completely blank, right? To get those actions into the center workflow, we have to look to the right.
We do. The right side panel is your payload bay, your library. This is where SAP Build houses all the pre-configured activities, the data types, and the logic controls.
It's like a toolbox.
It is a massive repository. If you want the bot to open Excel, you go to the right side panel, search for Excel, grab the Open Excel activity, and physically drag it over and drop it onto the center workflow canvas.
So we have the toolbar on top for saving and testing, the center workflow, which is the actual sequence of events, and the right side panel, which is our toolbox for grabbing new actions.
Yeah.
What about the bottom of the screen?
The bottom panel is the console. Think of this as the black box and diagnostic system of your aircraft. When you hit test, the console is where you will see the runtime logs.
That's where things go wrong.
Usually, yeah. If something breaks, this is where the error messages and warnings appear in red text. But beyond debugging, this is also where you access and manage the internal variables of your automation. When you create a data point that the bot needs to remember, it is stored and managed down here in the console.
So for you listening, I want you to actively visualize this. Or, better yet, if you are logged into your SAP BTP free tier account, click into an automation project and map these 4 zones.
Yeah.
Top is toolbar, center is workflow, right is library, bottom is console.
It becomes muscle memory.
Definitely. The vast majority of your time building automations is going to be this dance between searching the right side panel for a specific tool, dragging into the center workflow, and then checking the bottom console to make sure your variables are mapped correctly.
And once you're comfortable navigating that workspace, you need raw materials to work with. I mean, an automation is completely useless without data feeding it.
Yeah.
In our specific sales order management use case from the sources, the business goal is to stop a human from manually entering order details from a weekly spreadsheet into the SAP system.
Which means we need to stage that data perfectly. A bot cannot just look at a messy, unstructured spreadsheet and guess what things mean the way a human can.
No, it cannot.
Luckily, SAP Build Process Automation has deep native integration with Microsoft Office products, specifically utilizing the Excel SDK in the background. We are going to use an Excel file filled with our mock sales order data as our starting point.
This data preparation phase is a critical architectural step. You have to be exact here. If you're following along and building this, you need to create a new Excel file, and you must apply very specific column formatting.
So it's not just typing it in.
No, this isn't just about typing headers and making them bold. It's about defining the underlying data type for each column so the bot's memory knows how to allocate space and handle the information.
Let's pause there and explain the why. Because if I am a business user, I just type January 1st into Excel and move on. Why does the bot care if a column is technically formatted as a date versus a string of text?
Because machines lack intuition. If a column is just formatted as general or text and it contains 01012024, the bot reads it as a literal string of characters, a 0, a 1, a slash. It doesn't know it's a date.
Oh, I see.
So if you later ask the bot, is this order older than 30 days? The bot will crash because it doesn't know how to do math on a string of random characters.
Right, you can't subtract days from a word.
Exactly. By strictly formatting the column as a date type in Excel, when the bot imports it, it allocates that data into a date object in its memory, which allows it to perform chronological logic later. Type safety prevents catastrophic runtime errors.
That makes perfect sense. It is about translating human visual cues into machine-readable structure. So let's look at the exact columns you need to set up in your Excel file to make our use case work.
Get your spreadsheets ready.
First column header should be order number, and you must format that column as text. Even if your order numbers are just digits, format it as text because we don't want the bot trying to do math on an order number.
That's a great tip.
Second column is order amount. And you format that as a number, preferably with 2 decimal places. Third column is order date, formatted strictly as a date.
Continuing that structure, the fourth column is shipping country, formatted as text. Fifth is expected delivery date, formatted as date. And the final column is order status, formatted as text.
Okay, so 6 columns total.
Yes, and ensuring these cell formats are adhered to is non-negotiable. If you fail to format these correctly, the automation will either parse the data incorrectly or fail entirely when we try to bind it to a data type later on.
Now, normally a show might read you 20 rows of raw data right now, which is, frankly, terrible radio. We aren't going to do that. But the sources do provide specific mock data, like an order from the US for 400 grand and an urgent order from the UK. The point of injecting this mock data isn't the specific numbers. It's creating a controlled environment. When we build the logic, we need to know exactly what the input is so we can verify if the output is correct. If our test file has an order marked urgent, we can build logic to see if the bot catches the urgent flag.
Exactly. Staging controlled, structured data is what allows us to move from the preparation phase into the actual process builder. We are going to insert a new automation step that acts as a bridge between the trigger that starts the process and the system where the data needs to end up.
Here is where it gets really interesting. We have this flat, boring Excel file. How do we pull that into the bot's brain? I know we aren't just telling the bot to open Excel and read it line by line like a human would. There is a more elegant way.
Much more elegant, yeah. We are going to utilize an activity called the Excel Cloud Link. You go to your right side panel, search for Excel Cloud Link, and drag it into your center workflow.
What is actually happening under the hood when I drop that activity onto the canvas?
It is doing a lot of heavy lifting for you. When the automation reaches this step, it automatically opens a hidden background instance of the Excel application using the SDK.
So you don't even see it pop up.
No, it's invisible to the user. It looks at the file path you provided, grabs the entire range of data from your worksheet, and maps that flat tabular data into a dynamic, custom data type within the automation's memory. We will name this custom data type sales order data type.
So it's essentially taking our columns, the text, the numbers, the dates, and creating a structural blueprint, like a JSON object or an array, that perfectly mirrors our Excel feed. And all of that lives in the bot's temporary memory, or RAM.
Correct. The Excel Cloud Link activity has an output parameter. It takes all the records it just parsed and assigns them to an output variable. So now the bot doesn't need to look at the physical Excel file anymore. It holds the entire data set in its active memory, perfectly mapped to our structured data type.
But because it opened that background instance of Excel to read the file, there is a crucial easily missed best practice step we have to take immediately. I've seen automations completely lock up a server because developers forget this next step.
Oh, yes. You are referring to resource management. Step 2 is dragging the CloseExcel instance activity into your workflow immediately after the Cloud Link step.
Do not skip this, folks.
Please don't. Since the data is already extracted into the bot's memory, you do not need the actual Excel application running anymore. Leaving it open needlessly consumes system RAM. If your bot runs 100 times a day and leaves 100 hidden instances of Excel open in the background, your machine will eventually crash. Always, always clean up your application instances.
It is the digital equivalent of turning off the lights when you leave a room.
Uh-huh.
So the lights are off, Excel is closed, but our bot is standing in the dark holding a massive, invisible list of hundreds of sales orders in its memory.
Right.
We need to give it a mechanism to pick out the one specific order we actually want it to process right now.
That brings us to step 3, which is variable initialization. Down in the bottom console panel, we are going to initialize a new variable and name its selected order. We map this variable to our custom sales order data type, but we do not assign it any values. We leave it completely empty.
I want to make sure I understand the mechanics of this. Why create an empty variable?
Think of it like creating a blank template or an empty folder on your desk. The folder has a label on the tab that says selected order, and it has specific pre-printed lines inside for order number, amount, and date. But right now, those lines are completely blank. It is waiting to be filled with the details of the specific order the bot is about to hunt for.
Got it. So let's say the trigger form that started this whole process sends the bot an order number. A user in the logistics department types in PO7375 into a web form and hits submit. That order number gets passed to the bot.
Exactly.
How does the bot actually find PO7375 inside the massive array of data it's holding in its memory?
This is where we build the actual engine of the automation, the loop logic. If you are used to traditional programming, this is essentially a for loop. You go to your right side panel and drag a for each control activity into the workflow. We're explicitly instructing the bot to iterate sequentially through the entire list of orders we extracted.
I want to highlight the difference between human cognition and machine logic here.
It's an important distinction.
Because if I hand you a printed spreadsheet and ask you to find PO7375, your eyes intuitively scan the page, skip over the 1,000, skip over the 5,000s, and jump straight to the 7,000s block. You use intuition.
Right.
A machine cannot do that. Unless you build a highly complex search algorithm, a standard RPA loop evaluates sequentially. It operates in what computer science calls ON, time complexity. It has to check row 1, then row 2, then row 3, in order.
That is a vital distinction to make. The bot has no intuition. It needs strict instructions for every single step. So inside that for each loop on our canvas, we have to add a conditioned activity. The bot is looking at row 1, but it needs to know what it's looking for.
All right, so we take that order number the user typed in, PO7375, and we define it as an input parameter for our automation. And we set its type to a string, right, even though it has numbers in it.
Yes, it must be a string type because order numbers almost always contain alphanumeric characters like the PO prefix.
Yeah.
If you set it to a number type, it will fail to validate. So we have our target string, PO7375. Now we construct the logic statement inside the condition.
What does that actual mathematical or logical statement look like inside the SAP Build UI?
It is designed to be visual, but underneath, it is a simple Boolean evaluation. The statement asks, is the order number input parameter strictly equal to the order number field of the current member?
Okay, let's define current member, because I see that term trip up a lot of people who are new to visual automation builders. What exactly is a current member?
Current member is a dynamic, temporary variable created automatically by the for each loop. It represents the specific row the loop is actively evaluating at that exact millisecond. So if the bot is on its third time through the loop, the current member holds all the data from row 3 of your Excel sheet.
So let's walk through the bot's internal monologue for a second. The bot enters the loop. It looks at row 1. Current member is row 1. The condition asks, is my target, PO7375, equal to the order number in current member, which let's say is PO7991? The answer is false.
Exactly. And because it is false, the bot bypasses any actions inside the condition, hits the end of the loop, and cycles back to the top. It loads row 2, current member is now row 2, is PO7375 equal to PO79N8 false, it cycles again.
It does this blindingly fast, obviously, but it is doing it sequentially. Finally, it hits row 42. It evaluates the condition. Is PO7375 equal to PO7375? The answer is true. What happens the millisecond that condition evaluates to true?
When the condition is true, the workflow execution drops inside the condition block. This is where we place a set variable activity. Remember that empty template, the selected order variable we created earlier.
The empty folder on the desk.
Exactly. We configure the set variable activity to take the entire current member object, which right now is row 42, holding all the data for PO 7375, and pour it into our empty selected order variable. The blank template is now populated with the correct amount, the correct date, the shipping country, and the status for that specific order.
Brilliant. We captured the target. But, and this might be the most important conceptual takeaway of this entire build, we are not done. There is one more activity we have to drag into the true block. And if you forget this, your bot will be incredibly inefficient.
Oh, this is a big one. You must add a break or end loop activity immediately after setting the variable. Think about it. If your Excel sheet has 50,000 rows and the bot finds the target order on row 42, it has accomplished its mission.
Right, it has what it needs.
But if you do not explicitly tell the bot to break out of the loop, it will continue to blindly cycle through the remaining 49,958 rows, evaluating a false condition every single time.
Which spikes CPU usage, delays the process, and is just fundamentally bad architecture. It goes back to the difference between human and machine logic. A human stops searching the phone book the second they find the name. A machine will keep reading all the way to the letter Z unless you explicitly program it to stop.
Exactly. Adding that break command makes your automation elegant and resource efficient. Once the loop is broken, the heavy logic is finished. To finalize the build in the automation editor, you define your output parameters, passing that newly filled selected order variable out of the automation and connect it back to the overarching process workflow.
And there is a massive downstream benefit to doing this heavy lifting in the bot.
Mhm.
Because the bot is now capable of parsing the spreadsheet and finding the exact database on a single string, we can go back to our initial user-facing trigger form and simplify it drastically.
Huge UX improvement.
Yeah, we can delete all the redundant input fields like asking the user to manually type in the amount and date. The user only needs to type in the order number now. The bot handles the rest.
That is the ultimate goal of enterprise automation. You have dramatically streamlined the user experience, you've reduced the time it takes the human to initiate the process, and entirely eliminated the possibility of manual data entry errors. Once you run this through the test console and verify the variables are passing correctly, you release the project so it can be deployed.
Okay, I want to pivot here because this is where the theory hits the physical reality. We have built this beautiful, flawless logic. We have mapped variables and optimized loops. But right now, all of that logic just lives in the cloud, sitting on SAP's BTP servers.
Yes, it is isolated.
Right. How does a cloud-based logic flow actually interact with the local Excel application physically installed on a user's Lenovo laptop in a corporate office in Chicago? This brings us to the infrastructure setup.
This is the bridge, and it is arguably the most critical technical component to understand. The logic lives in the cloud, but the execution happens locally. We bridge that gap using a piece of software called the Desktop Agent 3.
I'm going to play the role of a highly skeptical InfoSec manager for a second.
Let's hear it.
You are telling me you want a cloud service to reach down into my corporate network, manipulate local files, and take over a user's screen. How is that not a massive security vulnerability? What exactly is this desktop agent doing?
It is a totally valid security question. The Desktop Agent 3 is an on-premise, lightweight component of SAP Build Process Automation. It is installed locally on the host machine, but to address the security concern, the cloud does not reach in, the agent reaches out.
Ah, that is the key distinction.
Yes, you do not have to open inbound ports on your corporate firewall, which would indeed cause InfoSec to shut you down immediately. The desktop agent establishes a secure outbound connection to your SAP BTP tenant via long polling or WebSockets. It essentially asks the cloud, "Do you have any jobs for me?" over a secure encrypted channel.
So it's constantly checking in.
Right. When an automation is triggered in the cloud, the payload is delivered securely down to the agent. The agent then uses local system privileges to launch applications, manipulate the document object model of web browsers, read screens, and enter data.
So it operates entirely within the security context of the local Windows user it is installed under. If the user doesn't have permission to open a specific folder, neither does the bot.
Precisely. It is an extension of the authenticated user. So if you are following along as a learner, your next major action item is installation and environment configuration for this agent. And you need to pay close attention here because there are two very different deployment paths depending on what type of user you are in the SAP ecosystem.
Let's break down those paths. Who gets the easy route and who gets the hard route?
If you are a standard enterprise user operating within a managed corporate tenant, you get the automated route. You navigate to the SAP Build lobby, open the control tower, which is the centralized administration hub for all your environments, and under agent configuration, you select Agent Update.
Very straightforward.
Yeah, this path allows the system administrators to push the installation centrally, ensuring your agent is always automatically updated to the latest corporate approved version.
But what if I am a developer testing this out on my own, or maybe a partner consultant? What if I am a P user? First, define what a P user is for anyone who might not be deep in SAP identity management.
A P user or public user is a self-registered user identity in the SAP community network, often used by independent developers, partners, or people using the free tier who aren't bound to a central corporate Active Directory. If you are a P user, the automated update tool won't work for you. You must take the manual route.
So where do I actually get the files?
You have to manually download the setup program from the SAP Development Tools website. It is packaged as an industry-standard Windows MSI installer. According to the current source specifications, you must ensure you download a minimum version of 3.7.41, but you should always just grab the latest stable release. You run the MSI installer locally on your Windows machine, walking through the standard setup wizard.
Click Next, accept terms, click Finish. Seems simple enough. But our sources highlight a massive pitfall right after installation. There is a step that is incredibly easy to forget, and if you miss it, your bot will just stare at a web browser and fail to interact with anything.
You were talking about the web browser extensions.
Yeah.
When the MSI installer runs, it physically places the files for the SAP Build Process Automation web browser extensions onto your hard drive for Google Chrome and Microsoft Edge. However, for security reasons, modern browsers do not allow third-party installers to silently activate extensions.
Right. The browser will install it, but it keeps it disabled to prevent malware from hijacking your session.
Exactly. So you must manually open your Chrome or Edge browser, navigate to the extension management settings, find the SAP Build Process Automation extension, and toggle it to Enabled.
Why is this extension so critical? Why can't the agent just look at the screen and click where I tell it to? Like if the button is in the top right, just tell it to click the top right.
Because screen scraping, just looking at pixels, is notoriously brittle. If a web page updates and moves a button 2 inches to the left, a pixel-based bot will click empty space and fail. The browser extension allows the agent to look under the visual layer and interact directly with the document object model.
Okay, so it's reading the code.
Yes, it reads the HTML tags, so it doesn't look for a blue button on the right side of the screen. It looks for the HTML element with the ID of suborder. Even if the web developer moves that button across the screen or changes its color to red, the bot will still find it instantly. The extension is the interface to the DOM.
That makes total sense. It's the difference between navigating by looking at a paper map versus having the GPS coordinates injected directly into your brain.
Great analogy.
Okay, so the agent is installed, the Chrome extension is enabled, and we can read the DOM. But right now, the agent running on my laptop still doesn't know who I am or which specific cloud environment it is supposed to be listening to. It is orphaned. We have to register it.
Let's walk through those steps exactly because the UI can be a little tricky here. Registration is a multi-step handshake between the cloud and your laptop. First, you need to generate a secret ID, which is essentially an API key for your agent. You go back to the cloud, to the control tower in your SAP Build lobby. You select Go to RBSC Portal, and you need to add a user.
Let me throw in a quick troubleshooting tip here. If you are in the portal and all the Add User buttons are grayed out, or you keep getting permission denied errors, you need to check your overarching BTP role collections.
Yes, very common issue.
You must ensure you have the Process Automation admin role assigned to your specific user account in the BTP cockpit. Otherwise, you have no authority to generate security keys.
Excellent point. Once you have the authority and the user is added, you generate a new secret ID. The system will display it once. You need to copy that secret ID string immediately. Then, you switch back to your physical laptop and open the Desktop Agent 3 application from your system tray.
So the agent interface pops up. What is it asking for?
It will prompt you for a tenant name. You can make this up. It is just a local alias to help you remember what it is connected to, like dev environment. Then, it asks for the tenant domain URL, which you copy from your BTP cockpit, and finally, it asks for that secret ID you just generated.
I paste the secret ID, hit connect, and the agent reaches out to the cloud and authenticates. But it still needs a specific bucket to live in within the cloud, right?
Yes. The final step is assigning the agent to an environment. Back in the Cloud Control Tower, you go to Tenant Configuration and select Environments. Think of an environment as a logical workspace. You might have one for development, one for testing, and one for production. You create a new environment, giving it a name and a description.
And then we assign our newly registered agent to this workspace.
Exactly. Inside that environment, you go to Agent Management, click Add Agent, and because you authenticated the agent locally a minute ago, you should now see your machine's name populated in the available list. You select it, add it, and the handshake is complete.
And how do I know if I did all of that correctly? What is the visual confirmation that the bridge is fully operational?
When you look at the Agent Management dashboard in the control tower, your agent will display a status icon. If everything is configured correctly, it should show a green idle state.
Green is good.
Green is very good. Idle means it is successfully connected, fully authenticated, not currently running any jobs, and is quietly listening for a command from the cloud.
Seeing that green idle status for the first time is incredibly satisfying. It means the infrastructure is sound. So let's take a breath and recap this intensive architectural journey we just went on.
It was a lot of ground to cover.
We didn't just talk about clicking buddies today. We started by identifying how to evaluate high-value automation targets, looking past the massive IT projects to find those hidden 5-minute swivel share tasks that quietly drain thousands of hours across a team. We explored the API dilemma and why RPA is the tactical tool for bypassing legacy development backlogs.
From there, we mastered the conceptual geography of the Automation Editor IDE, breaking it down into the toolbar, workflow canvas, library panel, and console. We learned that the workspace is fundamentally designed to support visual top-to-bottom logic construction.
Right, and we spent significant time on data prep, discussing why enforcing strict data types like strings and dates in our Excel file is critical for memory allocation and preventing runtime crashes. We didn't just read data, we built a structural blueprint.
We then translated that flat data into a dynamic sales order data type using the Excel Cloud Link. We built the core logic engine, deploying a for each loop to iterate through the data array, writing a Boolean condition to hunt for a specific string match, pouring that match data into an empty variable, and crucially implementing a break command to stop the loop, saving massive amounts of CPU cycles.
And finally, we engineered the physical bridge from the cloud to the local machine. We deployed the desktop Agent 3, navigated the security architecture of outbound polling, understood the critical necessity of DOM reading browser extensions, and successfully executed the multi-step handshake to register the agent in the control tower.
This foundational knowledge we covered today is the absolute bedrock for scaling enterprise automation. You are no longer just learning how to use software. You are learning how to translate messy, unstructured human workflows into highly structured, resource-efficient machine logic. You have the exact conceptual math and configuration steps to go build a production-ready automation in your SAP BTP free tier account.
So as we wrap up, what does this all mean for the future? We have built a solid foundation, but where is this technology actually heading?
This raises a really important provocative concept that I want you to mull over as you start building. Everything we designed today relies on rigid structure. You built an automation that mimics human clicks perfectly, but it relies on a static Boolean loop condition, and it relies on perfectly formatted Excel columns. If column C isn't a date, the bot fails.
It's rigid.
Very rigid. But imagine the evolution of this architecture. What happens when you replace that static loop condition with a pre-trained machine learning model?
Oh, wow.
Imagine a bot that doesn't need perfectly formatted columns or explicit if-then rules. Imagine an automation that can ingest completely unstructured data like the body text of a messy email from a frustrated customer or a poorly scanned PDF of a handwritten invoice and interpret the intent on the fly, dynamically making decisions about where that data needs to go.
That is a wild thought. We are talking about moving from robotic execution to cognitive automation. You don't have to program every single edge case because the bot can infer the context.
Exactly. What we built today are the hands. The hands can move data with incredible speed and accuracy. But the next frontier of SAP Build Process Automation is integrating AI services to build the brain. Once you combine the hands we built today with the cognitive brain, the scale of what you can automate becomes virtually limitless.
But you cannot build a brain until you intimately understand how the hands work, how the memory is allocated, and how the infrastructure is connected. So your final action item is open up your SAP BTP environment and get building. Stop doing the invisible, soul-crushing manual work and build the logic to let the bot do it for you. Take control of your workflow. Until next time, keep exploring and keep building.